All right, so today we're going to actually learn the little tricks for finding the derivative. So a few things. So the first one here says if you have a derivative of a constant, it's 0. So remember, derivative means the slope of the line. So think about that. If you have a horizontal line right here, what's the slope of this horizontal line? It's 0 everywhere. So that's why the slope, so the derivative of any number is going to be 0. And then most of you guys have figured out that if you have like x squared, we figured out that our derivative is always 2x, and that's because of the power rule here. So what the power rule says is that you take your exponent and you bring it in front, and then we subtract 1. So the derivative of x cubed would be 3x squared. I brought down my exponent and I subtracted 1 from it. Number 3, the constant multiple is just saying that if there's a number out in front, I multiply it by whatever the derivative would be. So the derivative of 2x to the fourth is 2 times the derivative of x to the fourth, which is bring down your power and then subtract 1 from it. So this would be 8x cubed. And then sums and difference rules just says that we can do this multiple times. So the derivative of this, so bring down your power, so 2 times 3, and then subtract 1 from it. Bring down your 2, so you do 2 times your 5, subtract 1. The derivative of any constant is 0. So the derivative of this function is this right here. So instead of doing that limit formula where you say as x approaches a and do the whole stuff and simplifying it down, this is the answer you'd get out if you use that limit formula. So then there's 2 rules in this section that get a little bit tricky. The first is the product rule here. So here's the rule, and it says if you're doing a u times a v, then you need to do u times the derivative of v plus v times the derivative of u. What typically you'll hear me in class, I call these 1 and 2. So I'll say leave the first alone, take the derivative of the second, plus leave the second alone times the derivative of the first. Now, a problem like number 5 here, you would actually just FOIL this out and then do one of the rules up here. It would be so much easier and faster. But I want to show the product rule right now with a very a simple idea so that when you get really hard ones, you're already in the practice of it. So I do understand I would FOIL these, but we're not going to do that right now as we learn the rule. So it says leave, I'm going to put it down here because I don't have room up there. So leave the first alone times the derivative of this part. So the derivative of 2x is just 2. Because like you bring down your power, which is 1, subtract 1 and it goes away. And the derivative of 2 was 0. And then plus, leave my second alone, 2x plus 2, times the derivative of the first. So the derivative of x, so it's just the number in front of it, so it's just a 1. The derivative of negative 1 is 0. So then you'd multiply that in, you get 2x minus 2 plus 2x plus 2. So our derivative of that would be a 4x. And the 2 and negative 2 are going to cancel each other out. We're going to practice some more of these on the back. All right, so now the product rule. So the product rule says is that you're going to have, so this is the bottom, the v is the bottom, and the u is the top. So it says you have the bottom times the derivative of the top minus top times the derivative of the bottom over the bottom squared. So sometimes like you'll hear professors use like low for the bottom and high for the top, so low and high. So they go high d, low d high minus high d low over low squared. I just remember I start with the bottom, and that's how I do it. And don't forget there's a minus this time. So up here in the product rule, it's a plus. But down here, when we're doing the quotient rule, it's a minus. So kind of remember like when we're doing logarithms, and logarithms, multiplication meant adding and division meant subtracting. So you can kind of remember that way. So division means subtraction here. So right here, the rule says take the bottom, so x squared plus 1, times the derivative of the top, so it's going to be a 2x, minus top times the derivative of the bottom, so the derivative of x squared plus 1 would be a 2x, all over my bottom squared. And then from here, we're going to go ahead and multiply out the top and combine like terms. So if this was not multiple choice, you could like leave it like this, but these will all be multiple choice questions. So we're just going to go ahead and practice reducing it. So let's see, that would be a 2x cubed plus 2x. And then this is going to be a minus 2x cubed. And then when minus 2x. And then distribute your negative to both those terms. So 2x cubed and a 2x cubed are going to cancel. And then 2x minus a negative 2x gives me 4x. So I get 4x over that bottom squared. So the only reason I have us practicing this is because these would be multiple choice questions and you'd have to be able to match your answer to their answer. And we'll practice a lot in this chapter of questions like that. The negative power rule down here is nothing different. It's just that kids forget how to subtract from a negative number. So that's why I threw these rules on here. So you still bring down your power and subtract 1. But when you're subtracting 1 from a -2, it becomes -3. It does not become -1. All right, on the back, I'm just going to go ahead and do all these problems. I would suggest maybe you pause the video right now, try some of these yourself, start watching it, pause some yourself, and so on, okay? So the first one, the derivative, oopsie. And when I do a notation y prime, that just means, oh, it's out of focus, sorry. Let me try to refocus the back now. All right, so y prime is just the shorthand for derivative. I could also do dy over dx, and that's what we're going to start doing later on in the chapter, but right now I'm lazy, so I'm going to use a y prime. So the derivative of that would be 8x plus 3. So again, on number 2, I would have FOILed it out normally, but right now, since we're practicing the power rule or the product rule, I don't know why it keeps unfocusing. Sorry, guys. So this one is derivative. Leave the first alone times the derivative of the second plus second alone times the derivative of the first, and then FOIL it out. So 4x plus 5, it looks like. And you know me, I can make math mistakes. So if there is a math mistake in this paper somewhere, feel free to let me know. So this one is the bottom times the derivative of the top minus top times the derivative of the bottom all over the bottom squared. So distribute your negative and make that negative x and a -1, combine like terms. So the x's would cancel, and I get -6 over x minus 5 squared. All right, on number 4, it looks like, oh, maybe quotient rule to this, right? I would not do quotient rule to this. Remember the rule, one thing on bottom, divide every single term by it. So really, this would be the same thing. So f of x would equal 2x cubed plus 3 plus 1 over x squared. Remember 1 over x squared, I'm going to write that as x to a -2, because then it's just a power rule. So now, instead of doing a quotient rule, we've simplified this, and we've gotten 6x squared. The 3 will go away. This will bring down my power, and subtract 1. So that makes it much easier. 5, you have to do a quotient rule too. So bottom times the derivative of the top minus top times the derivative of the bottom over the bottom squared. So let's see, so that gives me 2x minus 2x to the 4th, and this becomes plus 3x to the 4th. So we get x to the 4th plus 2x. And oh, that's a square down here. And sometimes when you factor the top, it will cancel the bottom. This is not one of those times, but I always do check to see if I need to factor the top to get the bottom to cancel. So on this one right here, this would be like a quotient rule with a product rule inside of it. You can do that. I probably am pretty lazy. I would go ahead and FOIL this out here. I think you get x cubed minus 1 on top, because that's what looks like a difference of cubes to me. Because you just square the first, multiply them together, square the last. Yeah, I think this is going to cube out to this. And with one thing on bottom, you could separate it and then get this. And then it's like so easy from here. You get 3x to a -4. You could have ended up with that if you did the quotient and product rule, but I'm kind of lazy right now. It's a Saturday morning. I'm making these videos, so. All right, and this is not. Well, you can look at those, I should say. I don't know why I crossed them out, sorry. All right, and then here. So these are just a fraction. So this is the same as 1/3 x to a -5, right? So just bring down your power, subtract 1. So that gives me -5/3. Well, it's -3/5 x to a -4 becomes plus 2 over 2 would be 1. So x to a -3 plus 1. All right, and then number 8 right here. Again, just remember, this is the same thing as 2x squared minus 2x to a -1 plus 5x to a -2. So that's going to give me a 4x plus 2x to a -2 minus 10x to a -3. And you might be wondering about getting rid of negatives in the exponents. And like we just don't do that in AP Calculus. If I'm trying to match an answer, I would say in the last 10 years, I don't know a time I've ever seen them like make you get common denominators and add the tops and problems like these. So it's totally fine to leave your exponents as negatives. If you wrote it as 2 over x squared or 10 over x cubed, that's fine too. Something like that. But besides, I don't really remember what these two problems are at this time, and I didn't bring the book home to tell you, but I'll look at them on Monday. If there's something important, I'll throw an extra little video on those. I'm assuming they're probably some sort of derivatives or something, but I'll look at them and make a video for those if I need to next week. So look to see if I have any addition for you, but you can look at the problems too.